We're at part 3 of pregnancy and human development on page 1071. Okay, and we just had in the last part, we had our stroll down the uterine tube here, and notice that this distance from here to here, that is to say from here to here, to go from morula to blastocyst, this is when hatching takes place, and we lose that outer shell now of the corona radiata, which is the zona pellucida, and it says right here that there's a degeneration of the zona pellucida, and so this is hatching out. The reason that we need to be hatched out at this point is we're hungry, and after all that cellular replication that's gone on, there's a need to ingest food, and of course mom is prepared for this because she has now grown her endometrium. The endometrium is in the secretory phase, and there's some really nice things at the vending machines here being secreted, glycoproteins. So your fabulous, good-tasting power bars and things like that are being displayed, and the blastocyst is able to take on nutrients. Eventually, the blastocyst has to sense where is the ideal location to implant, hopefully high in the endometrium wall is where implantation occurs. And as you can see here, it sort of buries itself. This outer shell here, which is referred to as the trophoblast, is actually filled with degradative enzymes that can actually melt right through mom's tissues on the way to where it is going. There is a little chemical signal also that it's called human chorionic gonadotropin, HCG, is being sent off, and it's being sent off ultimately over here to the corpus luteum. And the reason that it's signaling the corpus luteum is that the corpus luteum would be just about to, how shall I say, become a corpus albicans. It's about to end its existence in the ovary just at the time when implantation really needs to happen. So the HCG keeps it viable past its normal period of viability. And in fact, for the first 3 months of pregnancy, it's the corpus luteum that provides you with the estrogen and the progesterone and numerous other little molecules of interest. So this unit right here in the first trimester is what keeps the pregnancy going and viable. After 3 months of pregnancy, then the corpus luteum can take a rest because the placenta actually becomes the organ of endocrine secretion at the arrival of the second trimester. We'll get into that. There's graphs and charts here that depict that. Another thing that I want to emphasize here is that what a good deal it is for implantation to occur here and not someplace else like near the cervix or possibly up in this region here if there's any delay in the descent. And also, of course, that the egg was not dropped down into the peritoneal cavity where fertilization might have occurred, in which case there's a very ectopic pregnancy and could be life-threatening to the mom. So this is a very challenging system. It's a very natural one. It's not, at no time is there an emergency, and that's an important thing to recall and remember during pregnancy and also during delivery. Delivery itself is not an emergency. There's natural patterns and steady-state homeostatic conditions which proceed, and it needs some overseeing and guidance, but basically we've been doing this for hundreds of thousands of years. So it should go, in most cases, smoothly. But on the other hand, historically, women on average did not live to be as old as men. They didn't have the same longevity until recent times. In recent times, child delivery became more predictable and less life-threatening to the woman, and so women now actually outlive men. Okay, so that presses us on to this next scenario here, where we get to take a look at this blastocyst and the syncytiotrophoblast. Let's take a look here. Here is the trophoblast. This aspect of it has that nomenclature, this outer layer. And then check this out. Here these cells become sort of like phagocytic in a certain way, and they display their enzymatic abilities, and they get very, how shall I say, so excited that in some cases they literally merge with one another. And this is referred to then as the syncytiotrophoblast, where trophoblast cells sort of just throw themselves into the passion of eating away at the mother's endometrial cell tissues on the outside, and creates this sort of sinking pattern then where the we're going to actually sink beneath the surface here. In this next diagram on page 1073, we see how this occurs. Okay, and there's ultimately mom is welcoming and reaching out to the developing embryo at this point, and this is the syncytiotrophoblast. And then ultimately there's an arrangement made wherein the what's to become the chorionic villi in mom's vasculature reaches out to one another, and angiogenesis is the key here. We should have a film on angiogenesis that's discussed. Okay, so mother is actually growing arterial systems in order to reach out and to connect with the developing embryo. Here you can actually see embryonic development in its earliest stages right there. And now mom is creating these little lacunae here that interdigitate with baby's chorionic villi. Okay, so that's the ultimate thing here, is that we're interdigitating this developing organ called the placenta. The placenta ultimately develops further, and it becomes, the baby becomes so much larger than the placenta, but the placenta is quite functional at this point. Here we are at presumably 13 weeks of development, which is pretty much into the fetal stage now. We're past embryological development and into fetal development. And so the fetus is floating in the amniotic fluid and is becoming fed nicely by the... so this is just before this occurred. This is the 4.5 week stage here. 4.5 weeks is the middle part of embryological development, and not quite the fetal stage yet. And you can see at 4.5 weeks we're still surrounded by the placenta, and there's a yolk sac that's still there. But by the time we get to the yolk sac becomes very small in comparison to the developing fetus, and so the placenta is off to the side here. Here's an important graph that shows us the presence of this HCG, and let's take a look here. This is acting upon corpus luteum, so human chorionic gonadotropin. Remember, the corpus luteum lasts until 12 weeks, the end of the first trimester, and then the placenta takes over from there. And notice also here, I had to make a little correction, but the idea here is that there's supposed to be progesterone that is actually higher than estrogen. So the progesterone here is gone up. They're depicting this slightly off. I've made an alternate line here for progesterone to be higher than estrogen, and it's when progesterone drops below estrogen, that's when we get the false contractions. Okay, the Braxton Hicks contractions. So it's the quieting molecule is the progesterone.